Submultiplicative Glivenko-Cantelli and uniform convergence of revenues. A basic task in machine learning is, given access to independent samples from some distribution, to learn the cumulative distribution function, the CDF, of this distribution. For the case of distributions over the real numbers, the seminal Glivenko-Cantelli theorem shows that as the number of samples grows, the CDF of the empirical distribution over the samples almost surely converges to the CDF of the real distribution. The rate of this convergence was later quantified by Dvoretsky, Kiefer, and Wolfowitz, and by Massart. All of these results show that the CDF of the empirical distribution is close to the real CDF up to some additive error. Ideally, one may have wished to prove a stronger multiplicative bound on the error, however this turns out to be impossible. A natural compromise is to consider a submultiplicative bound, bounding the error at any point by epsilon times the value of the CDF at that point to the power of some alpha between 0 and 1. Note that alpha equals 0 gives the additive bound studied by Glivenko and Cantelli, while alpha equals 1 gives the unattainable multiplicative bound. Our main result shows that the case of any alpha that is less than 1 is indeed attainable. Our second main result furthermore quantitatively bounds the rate of convergence in the spirit of Dvoretsky, Kiefer, and Wolfowitz, as well as Massart. Indeed, letting alpha tend to 0 in our result recovers the upper bounds from these results. We demonstrate an application of our submultiplicative Glivenko-Cantelli bound to revenue learning, a problem widely studied in economics and algorithmic game theory. Consider a seller who has to decide which price to post for a good that she wishes to sell. Assume that each consumer draws her private valuation, that is, the maximum price that she is willing to pay for the good, from some unknown distribution mu. So, the expected revenue at price P is simply P times the probability of a random draw from mu being no less than P. The revenue estimation problem is, given samples from mu, to simultaneously estimate the revenue from all possible posted prices. More specifically, we ask when do the empirical revenues, calculated based on the empirical probability of a valuation to be no less than each possible price, uniformly converge to the true revenues. The main challenge is that the prices, as well as the possible valuations, are unbounded. Unfortunately, there is no upper bound on the rate of convergence that is only a function of the error bound epsilon and the error probability delta. Moreover, there is no bound on the convergence rate that is only a function of the three parameters epsilon, delta, and the expectation of the valuation distribution mu. In contrast, we show that when we consider any even fractionally higher moment of the distribution mu, we are able to use our submultiplicative Glivenko-Cantelli bound to derive quantitative bounds on the convergence rate. When the index of the moment that we consider tends to 1, then our bound diverges to infinity, reflecting that there is no bound that depends only on epsilon, delta, and the expectation. Nevertheless, we find that the expectation qualitatively determines whether uniform convergence occurs in the limit via a 0-1 law. If the expectation of mu is finite, then uniform convergence almost surely occurs. Conversely, if the expectation is infinite, then uniform convergence almost never occurs. Thank you for your attention, and we hope that you will take a look at our paper in the link below.